Okay, so today is March 27th, Thursday. So assignment 4 and tutorial 9 are due this weekend. And then tutorial 10, I expect to release, maybe today. If not today, then tomorrow. It is on the standard template library, which we've been talking about, um, and which, you're not permitted to use for assignment 4. Also next week, I will reopen all the old tutorials, or at least most of them. I might take because I did release some solutions, right? So there are there are some tutorials you could literally just grab a few files from the solutions and submit. Um, so most of the tutorials, if maybe all of them, I don't know. But yeah, so if you're not satisfied with your mark, this is your chance to earn a few extra points. It's best 8 out of 10, but if you do the 10, then you basically you can earn an extra 2%, right? So if you've done badly on one of your assignments, you can make up a lot of ground there. So yeah, I think the final exam next week, we'll talk more about it. I basically have something that I'm 95% satisfied with. It will be all multiple choice. Some general knowledge stuff, and then some what I call application programming, which is what you guys did on the tests, right? I give you some classes that all work together for some application, and I ask you to write some functions. Of course, you won't be writing functions, but you'll be choosing potential implementations, from some multiple choice list. But yeah, we'll talk about that next week, and I'll give you some materials to study for. Yeah, that's any questions about the. All right. Last class we were talking about the standard template library. However, as somebody pointed out in the section B, I asked you guys to do some file stuff on assignment 4, and I haven't really talked about files, so we're going to take a detour. Do a lecture on files. This lecture is short. It's like half an hour, perhaps. So it's not that accessing files in C++ is super complicated. It's not. But we're still going to go over the basic tools of how to do it. So files and streams. So we're going to talk about streams, we're going to talk about files, and then a little bit on error state flags. They will come up throughout. What is a stream? Well, this sort of ties into the standard template library and collections. It's a sequence of bytes. Typically we think of it as flowing from one place to another, right? I'm copying some bytes from here to there, perhaps from a disk to the RAM, so from disk to my program, or from my program to disk. But when we say streams, we say buffers, we just really mean a piece of memory, some information. But yeah, so I can send bytes from my keyboard to the program, or from my program to the console, or to a file, or to the network, or whatever. So for dealing with these streams, we have the input-output stream library, right? And so the parts of it that we've seen, well, from the input stream, we've seen the cin object, and from the output stream, we've seen the cout object. These are the standard input and output, right? This is keyboard, this is console. I haven't really talked about cerr and clog. Cerr by default goes to the console as well, right? It's just for error messaging, but I can turn off error messaging or redirect it to a file or something. So technically this is, although by default it is to the console, I can easily steer it somewhere else. Clog, I am guessing just goes right to file. I don't really actually personally have a lot of experience with it. Characteristics of streams. Well, our stream objects maintain these error bits. So if something goes wrong, these bits get flipped, and then we have to deal with the problem. Or we can check to see if something went wrong. The other thing we can do with our streams is we can test them, right? So if these bits get flipped, for instance, I have a good bit, and if I have there is a function called good that will return true if my stream is still good and false otherwise. But I can just do things like this. So this is, I'm going to overload the negation operator and the cast avoid operator. And what that means basically is that, let's say I open a file. A file is a type of input-output stream. Then I can write something like this. This technically does the cast to void operation. And if it's null, right, if my file didn't open, then this will return false. If I do have some valid file, then this will return true. Or all of this is just a fancy way of saying I can test my files as if they were a Boolean, right? And I can also do this. I could say, well, test the file and just take the opposite, right? So is my file not good? Then return true, etc. All right. So that is some streams basics. We're going to look at some examples now. And although when we look at these examples, we're going to be using cout and cin. These operations apply to all streams. And in particular, they also apply to file streams. Okay, so let's take a look. In the correct place, I believe so. Okay, we're just going to look at a few examples of how to use these streams, right? So in this case, well, this is, I mean, nothing we haven't seen before. I'm going to make two string variables and an int, and then I'm going to ask the user to enter two strings followed by an int. And then I'm going to start reading them in. So I'm just going to say while. So with this statement, what happens is, well, first we execute this. I read the first thing into my buffer into string 1, and then that returns this cin object. And so then I read the second thing from my buffer into C2. That also returns the cin object. I read the third thing into num. It returns the cin object, and then we do that cast avoid operation. And then it's basically, it's going to say, well, if nothing went wrong with that operation, keep doing it. So basically, this while loop will loop forever as long as I keep feeding it good information. And it's going to fail, well, reading into strings, it's a little hard to make it fail. All right, there are combinations I could do that are going to wreck it or like flip some flag. We will see those later, but for the most part, I mean, I could just mash my keyboard and it's probably going to be fine. But this is a little more sensitive, right? This stream extraction operator is strongly typed like every function in C++, which means that I'm passing in a number variable, and if I try to read in something that is not a number into here, it's going to flip some error bit, okay? So, and then we're going to do some other stuff after, but we'll figure that out later. Okay, so then that's all we're going to do. We're going to read in until I flip some error bit, and then I'll just say cout, all done. With some accidental caps, but that's fine. Make. Okay, so enter string number. So hi there 4 says you entered hi there 4. Great. Hi, enter there, enter 4, enter. 1, 2, 3. Well, 1 and 2 are numbers, but they can also be read into strings, right? That's not a problem. So to exit this, I need to enter something for this third variable that is not a number, basically. So I can write ABC, and then I'm done, right? So I flipped some error bit on this cin object and exited the while loop. Okay. Well, let's see what happens then. Which one of these? Let's do this. So what I flipped is the good bit, right? So let's try that again. I say A, B, C. Now the third one should be a number, so this is going to flip that bit. And when I test the good bit here, it's going to say that something is wrong, right? This stream is no longer good. I messed it up. That has other consequences. For example, I take this code here and say, enter another string and then try and print it out. And then all done. So A, B, C, C is going to wreck my stream. And it says enter another string, and then it reads A again, right? So what happened when I tried to enter this number is that this failed and nothing was pulled off of my buffer, which means that when I try to use this again, it's going to grab the next thing off that buffer. Not only that, I believe I can do, let's try putting that in a while loop. So I'm just going to keep reading and printing. Now, I swear to God, I've been proven wrong many times doing this example. Yeah, enter another string, all done. Yeah, so what happened is that it bounced out of this right away, right? So this good bit is bad and it stays bad, right? Even if I try to use it again, this is going to fail because I haven't reset the bits. Okay, so when my stream fails, if I want to reuse it, I have to do the clear. And then once I do the clear, I might still have stuff left on my buffer. We'll see. A, B, C, all is done. Enter another string. It says C. And now it's going to just keep repeating the things that I say. So it did read the next thing off my buffer, but hitting clear fixed this, so then I could, I can keep reading more strings. Anyway, so that's the basics of using these things with the cast avoid operation, basically until something goes wrong. Questions? All right. So let's test. Well, there's another, I mean, this is not so common reading from the keyboard, but let's say I do something very similar. I make a string, I read in, the user inputs a string, and I just keep going, reading in strings and then writing them out until I flip this other flag, which is the end of file bit. Okay, so again, not so common for cin, but of course, if I'm using a file stream, then this might be very common. I can enter the end of file marker from the keyboard using Control D. So this is going to keep looping until I hit Control D, at which point, well, we'll just do a little test. We'll test to see if it's still the end of the file or not, and then we'll take it from there. Did I end of file? Did I do that? Yes, okay. Okay, so hi, you said hi there, hi there. Control D says all done and still end of file. So again, if I flip this bit, it stays flipped basically until I clear it, probably. This has been giving me no end of problems every time I try and demonstrate it. So I can only guess what's going to happen this time. So hi there, Control D, no longer end of file, all done. Sure. But I cleared my cin. Let's try and use it again and see what happens. It's not up to date. I was getting some I swear, input buffers are the most confusing things to me for some reason. I cannot seem to get them straight as to, and there's always like some character left on it, like a new line or something that's going to ruin your life. Control D. All right, so no longer end of file, but I did have something left on the buffer that it read, but also like this exited right away. So even though it's no longer the end of file, for some reason maybe it read another end of file character. It's just bananas. I don't know. I can't get this this example to work correctly. Input buffers are they're going to be the death of me. Still end of file. So no longer end of file, but somehow without entering any characters, I guess I got to clear this this buffer. Maybe I could try something like this. Cin dot ignore. Just ignore 100 characters. That should take me to the end here. Control D. Yeah, I don't know. I tested here, it says, or sorry, I tested here, it says no longer end of file. And then down here, for some reason, it reads another end of file character without me actually doing anything. I don't know. You'd have to play with it to get it to work correctly. I I find input buffers. I mean, I just always forget. There's some, if you exit early, there's always something left, and that something will, you know, you may have noticed on some of the tests on the assignments that I asked you to press enter twice because I know there's a new line and I'm just lazy. Instead of clearing it, I just grab it. But yeah, anyway, end of file questions. All right, if you use end of file, I guess good luck to you. Luckily, we typically don't enter it from the keyboard. So when you reach the end of a file, generally speaking, you don't care. You're just going to close that stream anyway. But all right, let's look at. So that is what's called. Yeah. So we'll get back to this. But that is what's called formatted data, right? So when I use this stream extraction operator, well, I might do something like this. And this calls a function. And that function has very specific types. So on the left-hand side is an input stream, and on the right-hand side is, well, whatever that is. If it's an int, then I call the int version. If it's a time object, then I call the time version, if there is one, if I've written one. But the point is that it's strongly typed, which means that I can do formatting things. I can make assumptions, right? I can say, well, if it's a time thing, then I want to read it in this format. And when I implement this stream extraction operator, I can make sure that it's going to read something in that format. And then if something goes wrong, we flip one of the fail bits. On the other hand, maybe I want to read unformatted data from my stream, which is basically just, I'm going to read a bunch of bytes, and these bytes will be in a char format. And to do that, we're going to use get and getLine. All right, so let's, oh, sorry. All right, so the first thing we're going to test is get. This just gets a single character off my input stream. So I declare a char here, and I'm going to use these characters to build this string. And so basically, I ask the user to enter something, and then I just call the get function off this input stream. And I keep looping until I get a new line. Now, this is not going to execute right away. As soon as I call cin get, well, it buffers the input, right? And we flush the buffer when I hit enter. So once I hit enter, then all of this code will run. And it'll accumulate all of these characters, put them onto that string, and then print out the string. So I say, hi there, how are you? And then enter. And you can see where the while loop is executing and taking everything off that input buffer one character at a time, and then appending that to this string, and then at the end, printing out that string. So it says, hi there, how are you? And you know, the nice thing about this is now I get like fine-grained control over my buffer. And I can, you know, if I keep going until I see this new line character, then I can strip that new line character off, right? And make sure that there's not one waiting there. But yeah, that's questions on that. Okay. In the same sort of vein, well, grabbing individual characters is sort of, you know, low level and time consuming. And so we have a slightly higher level version of that, which is the get line. And now I'm going to read in an array of characters. So I'm going to make a buffer here, this string buffer that's going to read, you know, where I'm going to put my characters. And then I'm going to call the getLine function. So getLine, this is what I'm going to read into. And I'm going to read a maximum of 80 characters. So if I read more than 80 characters, it'll stop at 80 and leave whatever's left on the buffer. E1, hi there, enter. And you said hi there. So wonderful. I can, of course, read less than the size of my string here, or my, you know, character array. So yeah, let's get rid of the first one. You said hi, now it's waiting for another one, but it's only going to read 5. So I'm going to say hi there, how are you? And it says, you said hi there. It read 5. Well, it read 4. And well, the 5th character, of course, is a terminator, the null string ending character. I could also, you know, technically I could read more. I could read like 85. And if I enter more than 80 characters, I'm going to have a problem. I might get a seg fault or whatever. All right, it's C++, so this is, you know, the user has to be responsible enough to get these numbers right. I can also take everything off of the buffer until I see a particular character, right? In this case, when I call the regular get line, it flushes it once I hit a new line character. And it's still going to do that, but it's going to keep reading from my input buffer until it sees a star. All right, so let's try that. So hi there, how are you? Enter. Still reading. I am well. Enter. Okay, star. I am going now. And it reads everything up until the star, right? And then technically, this is still left on your input buffer. So the next time you go to read something, well, you might have to flush your buffer first if you do not want this old data getting into your, say, new variables. All right, so that's basically get line. Questions? Okay, so this get and get line, again, we're using them on these input streams, but you can use them on file streams as well. We are going to also look at, well, let's look at file streams. We're going to use file streams, though, with the unformatted, or sorry, the formatted data. As mentioned, this stuff will work as well. But so what we're going to do, and okay, should be fine. Okay, so we are going to Well, we're going to make a bunch of students. We're going to make a bunch of students and write them to this file, students.txt. All right, so how are we going to format them? Well, first of all, let's talk about this output file stream. So I make an output file stream object called outFile, and I give it a name. This file exists, and if it didn't exist, it would get created. Um, and then I'm going to do the not operation. So did I succeed? Like something could have gone wrong. And if it went wrong, then I'm going to exit, right? I don't want to start writing to a non-existent file. So assuming everything went right, I'm going to ask the user for a bunch of student information, number, name, major, GPA, separated by spaces. And then I'm going to, well, exactly as we did before, we're going to read it in using the standard input. I'm going to read in a number, a name, a major, and a GPA. And then I'm going to use those things to create Stu, the student. And then I'm going to print student to the standard output. And I'm also going to send student to the out file using this same operator. Okay. And then once I'm done, we're going to close the file. Technically, I don't have to do that. Because this is statically allocated, the destructor will close that file for me. But I'm a good programmer, so I'm being a good, well-behaved programmer. So I'm going to close it. Nothing to be done. All right, so enter student number, name, major, separated by spaces. So student number 1, name is A, major CS, GPA 10.0, enter. And we can see it read in these things, it made a new student, and it printed it out to the cout, right? So we've overloaded this stream insertion operator, and yeah, we implemented it here, right? So this will nicely format all of this information and print it out. And then, so we printed that out to the standard output, the console. But also this, the students.txt, right? So the exact same thing that was printed to my console here also got printed to students.txt. This file is still open, so let's enter another student. Student number 2, name is B. They are in math, and they have a 9.7. And there, student B to the console. If I look at here, oh, no. There we go. So once we refresh it, the second student is written to that file. Let's make one more. Student 3, number C, or name C, history, and 5.5. And there's student number C. And if I guess, go away and come back, student number C is written there. All right, so how long, this is going to keep looping until I either enter something wrong, which means that probably I have to enter a character where I went to read this, this letter, or sorry, this number, or I can hit Control D, right? End of file, Control D. We're done. Student.txt now holds all this student information, and yeah, so my stream insertion operator, I can send it to the standard output. I can also send it to a file stream. Okay, questions? Okay, great. How about reading from a file? Well, I'm going to do something very similar. Not quite exactly the same. I'm going to make a vector that I'm going to store all the students I read from my file in. I have some temporary variables, right? When I read the information in, I'm going to throw them in those variables. And then I'm going to construct a student, and then I'm going to push it onto the vector. So I open this same file, but now as an input file stream. So students.txt. If something went wrong, I exit. Now pushing students onto the vector. What I'm going to do is actually very similar. So what did we do over here? When I wanted this information from the student, I did, or from the user, I did this. So I'm gonna basically do the same thing. But not CN anymore. I don't want that. I want to read from in file. Okay. So I'm going to read it into these variables. Now, it's not quite coming in the same way that I typed it in, right? When I typed it in, it said enter number, name, major, GPA separated by spaces. But if I look at my students.txt, well, the first thing it's going to read is not the number, but this word, this token, right? So student colon. I don't want that. That's not my student number. And that's not my student name, and that's not actually any relevant information. That is just formatting. So I actually just want to read this, throw it away, and then start reading my student information. And then actually, when I get down here, I want to read this and throw it away, and then continue reading my student information. So here, the first thing I'm reading is number, but I have this extra string here called garbage, which is just stuff that I have to read it in, right, using this format. But I'm going to throw it away after. I don't really care about it. So I'm going to read in garbage here, and then also here, right before I read my GPA. Okay, and then I should have enough information to construct my student. So I'll say, what's it called? Push back. Well, I'm going to make a temporary student object. Puts number, name, major, and GPA. And yeah, so this vector is a vector of student objects, and which means that I basically have to do this. I have to make a temporary student object and push it onto my student vector. It'll get copied into my student vector. So I'm making like one more copy than if this was a vector of pointers, I could make it slightly more efficient, but that's fine. So we should have this student on this vector. This will exit, of course. Well, how did we exit before? We hit Control D for end of file. Well, there is an end of file marker at the end of this file. We can't see it, but it does exist. So this should exit as soon as I'm done reading all the students, and then it'll print them out. Okay. All right. So here is my list of students now. It read them all in from that file and printed them out. And I mean, basically, I guess, to prove that, I'm not making this up, let's add some information here. So Amber, Bob, Carl. Bob does not like math, maybe basket weaving. All right. I messed up the formatting, but that's not important because it's just, it goes by white space. So now when I run my code, I get this new information. Amber, Bob, Carl, basket weaving, etc. Okay, questions? All right. Well, this is actually not exactly, I mean, this works, but why am I doing all of this manually when I could be just doing something like this? I mean, I have a built-in operator, so let's make a temporary student stu, and then I'm just going to say, well, read in stu from this stream, this file stream in this case, but any stream. And when you're done reading in stu, push stu onto this vector. Right, so stu is just going to hold all of my information temporarily. And if I look at, well, I mean, I did this earlier, I guess, but I've overloaded this stream extraction operator. So I take an input stream, I read it into a student, and in the implementation, well, I do the exact same thing that we did over in the main function before. I have variables stu.number, stu.name, and stu.major, and stu.gpa, so I don't need to make those variables. I still have to read in these extra tokens, right? This student colon and GPA colon. I want to read those in and kind of throw them away. So yeah, so I make a string garbage here and I just read the garbage in. Read the garbage in, just ignore it. And then at the end, I return the stream. So this should basically, this should work exactly the same as it did before. The nice thing is now, I can make my input stream and my output stream consistent, right? So then I can write to a file in a certain format, and then when I read from the file, I can expect the same format, and then everything will work nicely. And my objects know how to write and read themselves to and from a file. All right, questions? All right, that's it for files. Again, short, 40 minutes, I guess. So yeah, on your assignment, I don't ask you to do anything this fancy. Basically, I ask you to do something very simple. When we construct our media objects, there is a file name. I forget what I don't know. Maybe I didn't, I forget what it's named. I don't know if I asked you to name it or I named it. Let's call it a video file. It's a file name. You're going to open that file. That file is just some ASCII art, and then you're going to read it line by line and then send it to the standard output. Okay, so that's all you want to do. You want to read from the file and write it to the screen. And, and you don't really have to do anything fancier than that. So yeah, questions? Okay. What is happening? Oh, Windows. Something about the renderer is... All right, so that's the end of files. Yeah, so what is a file? I guess we could have done this earlier, but a file is just a stream. It's just a sequence of bytes kept in persistent storage, also called non-volatile storage. So what does that mean? That means when I turn the power off, the information is still there, right? If it's non-volatile storage or persistent storage, like your disk drive or your SSD, I turn the power off, and then I turn the power on, and the information's still there. As opposed to volatile storage like RAM, when I turn the power off, anything stored in RAM is gone. Input stream UML, you don't have to know this. I don't remember where I picked this up, but I don't fully understand this thing. I think actually for it to be complete, we would have to do something like this. Oop, not here, sorry. Would have to look something like this. So we have an input stream and an output stream and an input-output stream using multiple inheritance. And then we have a file stream and an output file stream, and then but I don't know. Yeah, you could do that using virtual inheritance. Anyway, I can't quite figure out how they did that. So this input file stream class or library is derived from the input stream library, and the output file stream is obviously derived from the output stream library. Both maintain a file buffer object, and although it's a good practice to close it, as long as it's statically allocated and it goes out of scope, the destructor will close the file for you. And we can test them the same way we test regular streams, right? I could say if in file, as we've seen. Yeah, there's other functions if you're interested. You can flush a stream. You can this would put, a single character onto my into my file, if you like. Some of the bits, so as mentioned, they have these bit flags, and so you can use bit masking and stuff to access individual ones, or you can just use their functions that they provide, right? So these will return true if those bits are flipped, and false otherwise. Yeah, also the end of file, and clear should reset all of the flags. This end of file, from what I've read, the reason why it's not working correctly is because it's not expecting it from the keyboard, right? So I don't know, but to be honest, I'm not sure what exactly happened there. But yeah, typically you would use it from you would read it from a file, and then once you're done, once you read the end of file, then you're going to close that file anyway. So it wouldn't or shouldn't present a problem in the correct context. Okay. So yeah, unfortunately, this was a last minute. I just realized yesterday, or some student brought it to my attention that, hey, you didn't teach us files. So I don't have a woo clap for this, unfortunately. I have one for the STL, but yeah, so we'll continue with the STL now. All right, so standard template library. Well, we were actually just talking about streams. So a stream, we can treat these streams as containers, right? So our input stream and our output stream can be treated as containers, and as such, we can use iterators to access them. Right, so this is another way. You don't have to use iterators on your assignment. So I'm not trying to confuse anyone, but we can use them, and I'll show you how. Right, so if you recall last class, well, let's see here. Yeah, so last class we were here looking at iterators for the list class, right? So the problem was we had vectors, and well, vectors have random access, and right, so I can just use the subscript operator to access members of my vector class. With the list, it was not quite clear how we access members of my list, right? So I mean, we could write a for each loop, but a for each loop doesn't give me that fine-grained control, right? I can only just sort of march from beginning to end through my list, and maybe I want to like stop somewhere and back up and do other things. So that's where iterators come into play. Iterators are essentially the the abstraction layer that allows us to access things that are in my containers in the standard template library. And for my list class, they are basically, the sort of, maybe the preferred way to do it. These iterators behave a lot like pointers. They've overloaded these pointer operators the same as we did for our smart pointer. So we can do things like dereference it. We can do things like use the arrow operator to access the students underneath, etc. So that's where we left off last class. So now we're going to look at an example. We talked about how there are different classes of iterators, right? There's the very basic iterators all the way down to the random access iterators. And this iterator, this list iterator, is somewhere in between. It's a, what's it called? A forward and a back iterator. And but we're going to look at a stream iterator, which is one of the simplest types. Allegedly, here it is. Okay, so we saw files and streams, and to be honest, I really kind of like this format. I like the stream insertion operator. I think it's elegant, right? I can just throw objects at it. If I've overloaded that stream insertion operator, then it's really simple and really powerful to use, right? I don't have to worry about all these little implementation details. Those are handled somewhere else. So we're going to take this beautiful paradigm, and we're going to make it pretty ugly. We're going to wrap it in an iterator, an O-stream iterator. Call it OIT. And well, this O-stream iterator needs a stream to work on. So we're going to give it the standard output. Oh yeah. Also, it is a templated class. So I need a type. To start with, we're going to work with strings. Right? Strings are the most versatile. All right, so I've wrapped this in an iterator. What does that mean? Well, it means I could do stuff like OIT equals hi there. Ta-da. I'm going to use the \n because, well, because now we're, we're taking that beautiful thing and we're making it kind of ugly. $17. P5, yeah, all right. You're fine. All right, so P3 is okay though. That's what we're primarily worried about. Hi there. Okay, so I took this string literal, and I assigned it to this iterator, and it printed out hi there to the screen. All right, great. Let's try that again. Equals, please enter 2 words. Yeah, we don't need a new line there. Please enter 2 words. Okay, let me just fix this. I'm going to keep on doing that. Okay, so I want to enter something. Well, let's make an input stream iterator. Again, read in strings. We're going to wrap C in. All right, so now I'm going to make a string word 1 and word 2. And well, here I assigned a string to my output stream, but the input stream kind of works in reverse. So I'm going to actually assign what's on my input stream to my string, right? So W1 equals IIT. All right, well, the compiler doesn't like that because I'm trying to assign an iterator to a string, and that's, right. So here, they overloaded this operator so that, it accepts a string. But here, I can't overload the string operator to accept an input stream iterator. So what I have to do is, why does it do that? What I have to do is dereference it. All right, so when I dereference this iterator, it's going to give me what's on the stream. And then I will say yt equals you entered for W1. And then I can use this string concatenation now and add a new line character after. Right? I don't get end lines anymore, right? Because OIT, technically I could put this to an output stream. However, this output stream iterator only accepts strings. It doesn't accept whatever this is. So I need the new line character now. All right, so let's read in that first word. Please enter 2 words, hi and there. It says you entered for W1, hi. All right, let's grab W2. Enter two words, hi and there. It says you entered for W1 hi and W2 hi. Okay. So the input stream and the output stream are a little bit different because the output stream, as soon as I send this, it gets flushed to the console, right? So we can take a lot of liberties with the output stream that we don't necessarily take with the input stream. So here, when I read in the first token off the input stream, it's still there. It does not get removed. So if I want to remove it, or if I want to advance my stream, well, I'm going to use the plus plus operator. I just wish this, I mean, I like IDEs and they're very helpful, but sometimes I wish it was a little less aggressive with how much stuff it just throws in the middle of my screen. Anyway. All right. So we have to advance the iterator in this case. So W1 is high, W2 is there. Okay, so yeah, once I advance, I can read the next thing off my input stream. I don't really have to do that with my output stream, right? Although I can, it's not going to affect anything. It has overloaded that operator, but it just does nothing. So hi there, please enter two words, hi there. And so yeah, this does nothing. Also, I mean, this output stream iterator has overloaded this assignment operator. I could actually just dereference it. When I dereference it, I get back, well, I get back a string that I can then plug that into. So both of these actually work, right? Whether or not I dereference it, whether or not I advance it, the output stream is going to work the exact same way. All right, questions? No, okay. How are we doing? Half an hour. All right, let's see how far we can get through this. Okay, so we're going to use this output stream. Actually, we're not using the output stream. Not yet. We're going to start with the input stream. Why aren't I using the output stream? All right, we're going to make a vector of strings. We're going to have this string. And we're going to wrap our cin in an input stream iterator. And then we're just going to keep reading until the user enters this end, right? So while this string is not equal to end, push the string onto the vector, advance my input stream iterator to the next token, and grab the next token. So yeah, let's start by just running that. It's not going to do anything, but enter words ending with then. So hi there, or end. Hi there. Well, it doesn't end. How are you? And then end, and then there we go. Okay. All those are on my vector. I want to print those out. I'm going to make a stream iterator. See where? Okay, I can't see when it does that. That's too aggressive. Cout. Okay, so we've wrapped this up. Now I'm going to use, you can see here that I've included the algorithms library. So I'm going to use a function from the algorithms library, this copy. This copy function takes 3 iterators. So stuvect.begin, right? As we mentioned, that's an iterator that points to the first thing in my vector. Stuvect.end. So I'm going to copy everything from this first iterator to this iterator. And I'm going to copy it onto another iterator, in this case, the output stream iterator. Oh, it's not stuvect, is it? It's words. Okay. All right. So enter words ending with end. Hi there. How are you? End. And it says, hi there. How are you? Okay. Well, it's not, not Not great, but it's a start. So we copied everything from words.begin to words.end onto the output stream. It printed it to the standard output. Not a big fan of the formatting, so we can say when we create the iterator that every time we add something to the stream, then we add one of these tokens, right? So it's a separator. Hi there, how are you? And then we get hi there, how are you? I'm of course not restricted to just spaces. I can put whatever I like as a separator token. There we go. Okay. Yeah, I think that's about it for that. Questions? Okay. All right, so yeah, here's just a short review of some of the things that we did. The word token, yeah, I keep using the word token, eh? Because I'm used to, I think that comes from, I believe that's the correct term for, right? But I got it from using, when I used to program in Java, they had what's called a tokenizer. And so token is really just, I take some stream, in this case, a string, and I break it into tokens. And the typical way to break it into tokens is by white space, right? So I break it into words. But tokenizer just means that I'm taking some larger piece of data and I'm breaking it into smaller pieces that are called tokens. So yeah, I keep, it just seems like the correct word to use there. I'm not super, right? I'm not really going to ask you the definition on the final or anything like that. It gets flushed right away. I would have to double check that, but it does seem that way, right? So typically, let me think for a second. It does seem to be doing that, but I would have to look it up to verify. Yeah, no, I know what you mean, because whether or not I include, usually it'll flush a stream on a new line. That's sort of default behavior for streams, but it's, in this case, it's printing to the console even when I don't have a new line. So perhaps the output stream iterator flushes on every call to it. But yeah, I'm not exactly sure. It's a good question. I don't really have the answer at the moment. Maybe I'll look it up for next class. Other questions? All right. So yeah, now basically we took what I thought was quite an elegant solution, and now we wrapped it in iterators and made it basically as ugly as possible. But the nice thing is now that if we wrap the output stream in an iterator, I can use it with the algorithms library. So yeah. All right, so other parts of my standard template library are sequence containers. Sequence containers are containers that retain the order of their elements. That's basically everything you've made so far for your assignments. We've made array-backed collection classes and linked list collection classes. We haven't done a deck, but those are all sequence containers. In the standard template library, we can do things like query what's at the front, what's at the back, and we can add and remove to and from the back pretty easily on just about everything. Removing from the front, maybe not so easy. Yeah, we'll talk about this during the example, but I think we've covered this idea multiple times. As I add things to the vector, the backing array is going to grow. And as it grows, it's going to copy everything over and destroy the old array, which can be expensive. But yeah, we can, well, let's just jump into the example. We're going to use vector or iterators on our vector. Which we kind of already did, right? We did the copy words one to the end, but yeah, let's do it again. This is basically the same example as before. I'm going to enter a bunch of words ending with end. They're going to push them onto a vector. And then we're going to copy them to the output stream. And then we're going to do some a bit fancier stuff. So hi there, and so hi there. Okay. Well, that's copying things to the output stream, but this copy function takes 3 iterators, and all right, also you can just make your own iterators, which did I do it here? Yeah, I did. We'll take a look at that later. It just takes 3 iterators or anything that looks like and works like an iterator, right? You can write your own iterators. You just overload the correct operators. Basically, you need dereference and you need plus plus. Probably some other ones for certain special circumstances, but for copy, that's all you need. But so I can really throw any iterator in here, including ones that I make myself, and or including another vector. So I can copy everything from one vector to another. So instead of copying words1.begin to words1.end to the output stream, I'm going to copy it to words2.begin. Now, the peculiar thing about iterators is that, well, what does words2.begin point to? You can think of it as a pointer, but my vector is empty when I make it, right? So this points to nothing. So if I run this, hi there, and I get a segfault, right? When it tries to copy things to my second vector, let's just get rid of this guy for now. So I'm going to read everything into words1, which is a vector. Then I'm going to make a second vector, words2, and I want to copy everything from words1 to words2, and then I want to write it. Then I'm going to output words2 to the screen. But I got a segfault because this is actually empty. I don't have, my iterators do not make space. They do not call push back on this. So when if I want to copy everything from words1 to words2, I have to make space in words2. So when I initialize it, I'm going to make sure it's the same size as words1. Right? It's going to have a bunch of empty strings in there. But now when I call this, I should be able to copy those things from words1 to words2. Hi there. How are you? And then I copy them from words1 to words2, and then I output words2, and it says, hi there, how are you? Okay. That's a little awkward, right? And maybe I don't know necessarily when I create words2 how much space I need. So there is a second way to do this using the back inserter function. So I can, this is just a convenience function from the algorithms library. It's an iterator. It returns an iterator on words2, but then every time I add something to words2 now, it's going to call a pushback on that. So I should get the same result. But now I don't need to know the size of words2 in advance, right? So outputting words2, hi there. Also, as mentioned, how much time we got? Well, here I was just playing around before class, and I made my own iterator. Just a class, just a wrapper, and I overloaded the plus plus operation and the dereference operation and some other stuff, but these are the only 2 that get called. And so I can just, instead of using a back inserter, I can use my iterator. And it does the same thing as back inserter does. It just calls pushback every time. Hi there, how are you? And I meant, yeah, so some debugging stuff. But hi there, how are you? And then there's an extra token. It was, I just left it like that because there's a lot of edge cases to try and figure out if I didn't leave that extra token. But yeah. All right, questions? Okay, so that is the power of C++, right? As long as my thing compiles, all right, this is a template. This is a template library. So the only restriction on type is, well, does it compile? And my iterator happens to compile with this function, so yeah, that works. All right, let's do. So we've looked at vectors and we've pushed things onto the back and we've iterated over them, but we haven't really done anything, any fancier types of manipulation, right? So maybe I want to insert somewhere in the middle of my vector some value, or maybe I want to delete something from my vector. We haven't really done that. So the way we can do that is with this library, the algorithms library and iterators. So again, I make words one, and I push those words onto vector, I ask the user for a bunch of words, I push them onto words one vector. Down here, I'm gonna make a second vector called words three and enter words to insert. So I'm gonna push a bunch of words onto that, and then I'm going to insert those words into words one. All right, so I'm gonna call this insert function. So words one dot insert, which is a little weird, right? This is a member function of words one, and I have to explicitly pass in words one dot begin. It doesn't really make sense to me, but so yeah, I'm going to insert at the beginning of words one everything from words three dot begin to words three dot end, and then I will output them to the output stream. I should, I think that's okay. All right, so enter words to insert before hi there. So how are you? And so it says, how are you inserted in front of hi there in words one. Okay. I could also, of course, I don't need to pass an iterator. These are just strings. I could say like, hey, insert, a single value at the beginning. So hi there. Oh yeah, and then it just inserts hey. But also I can, well, this is the vector class. Vector has random access. And so my iterators also have random access, which means I can do pointer arithmetic, which means maybe I don't want to insert at the front. Maybe I want to insert at index 2. Well, I just add 2 to that iterator. And then uh, either end, how are you, and then it inserts it at index 2, which is after hi there. Or I can do either how are you end, and then Bob was here. I can insert that right in the middle. So Bob was here in between hi there and how are you. So yeah, that's how we can add and remove things from our vector class. And we can also erase. So using a similar idea, words1.erase takes in this case, 2 iterators, the beginning of the things I want to erase to the end of the things I want to erase. So I want to erase everything from 2 to 4. And Bob was here. And then hi there. Oh, yeah. Well, I should. Geez, all that work, and I didn't even write it to the screen. All right, so hi there, how are you? Or, hi there, Bob was here, how are you? And then I erased words from 2 to 4. It says hi there, and then it removes Bob was, and then here, how are you is left. Okay, so we can manipulate our vector, add things and remove things. Questions? Okay. So we got, get rid of all of this. 10 minutes. Feel like, I feel like we need a woo clap to break up the class. Otherwise it gets too monotonous just going over this code stuff. But no woo clap today. We're gonna power through. So I'm gonna make a bunch of students. I'm gonna push them onto a vector of student objects. Obviously, this is going to make a lot of copies, right? As the vector increases in size, because it is a vector of student objects, it has to, create a new backing array, copy the students over, destroy the old backing array. But all of this is, once I'm done, I'm going to have 4 students on my vector. Let's say now that I insert a 5th student, but I insert that 5th student at the beginning of my vector. Well, after I insert Zeke, or, while I'm inserting Zeke, of course I copy Zeke onto my vector, but also everybody else gets copied, right? Because I have to make space at the beginning of my backing array. If I look at the memory of this, I have something that looks like this. And then I want to insert A at the beginning. Well, I have to copy things over to make room. So D gets moved here, C gets moved here, B gets moved here, and then A can be placed in the beginning. All right, so vectors are very nice for most of the things you want to do. If you're inserting at the beginning of a vector, and especially as that vector grows larger, it's going to be a very expensive operation, even for just things like primitives. But here I'm copying whole student objects. All right, so yeah, not good. Yeah, so that's, I mean, I think that should be, I could copy things in reverse to my output iterator if I like as well. And yeah, if I want to copy from one vector to another, I have to be careful that there's enough space, or else use a proper wrapper for it. So that brings us to lists. So we've seen how to access elements of our vector. We've seen how to insert and remove, and we're going to do the same thing now for our linked list. I'll try and do it quickly. So again, I'm going to make a bunch of, well, here we're now students. So we're going to make a bunch of students. We're going to push them onto the list. We're going to copy them to the output stream. All of that is pretty standard. Let's make sure that that is working correctly, and then we will do something slightly fancier. All right, so I pushed my 4 students on. No mention of when they're copied, but that's fine. I don't really care about that right now. What I want to do is insert, right? I know how to access the students using these iterators. Well, let's say I want to insert Bob at the beginning of the list. Well, I can grab the iterator pointing to the beginning and then call the insert function on it. And that should put Bob at the beginning. So Bob gets inserted to the beginning. Okay, great. Also, let's take a look in constructor. Take a look at when these copies are being made. Okay, so one copy is being made every time I copy a student onto the list. When I add Bob, a copy of Bob is made, but I didn't have to do the thing that I did with the vector where I had to copy everything out of the way to make room. Again, this is a linked list. It's easy to add stuff to it, right? I just make a new node. Wherever it is in memory, they're connected by pointers anyway. So they don't have to be next to each other or in any particular order in memory. The pointers, put the order on them. But let's say I wanted to insert Bob now, maybe not at the beginning, but like 2 in. Well, we did that, right? For our vector, how we did it was we did this. We said, well, let's just jump 2 over. Unfortunately, we can't do that with a linked list, right? Because a linked list doesn't have random access, which means I can't do pointer arithmetic. I have to, basically the iterator behaves a lot like a linked list in that if I want to go forward 2, well, I start at the head of the list and then I say, my current node equals current node dot next. And that's basically what this plus plus IT does. And then that gives me to location 1, and then to step to location 2, I do it again. So linked lists, I have to manually start at the beginning, walk to the location that I want, and then I can insert Bob in the middle there. Right, so this is what's known as, these are known as abstractions, right? These iterators, they're convenient. They provide a nice, they provide an interface that's the same. For some reason, I can't think of that word. Standardized interface. But like all abstractions, they are leaky, right? Here, it is pretty obvious I'm dealing with a linked list because I have to traverse it like I would a regular linked list. There are convenience functions to do that for you. Advance, what is it? IT2, right? So this will take, instead of having to manually maybe write a for loop, and I can just say, well, please advance this iterator 2, and then Bob gets inserted in location 2. All right, and that is, so yeah, that's the big difference between iterators for the linked list and the vector. The vector iterators have random access, the same as the vector class. The linked list iterators, well, you have to kind of walk through each individual node to get to where you want to be. So here I've only displayed insert, but erase works the same way, right? If I want to erase something, well, I mean, I can just do this. Right, I want to erase just the second element there. I have to manually walk there. So that's Stanley, and now Stanley's gone. List.next. Yeah. Not that I know of. I think it's just a plus plus, right? But let's see. IT dot, does it give us anything? Just a bunch of operators. Yeah, so the iterators overload these operators. With good reason, I think, right? Because as mentioned, I mean, we're almost done here, but as mentioned, I take it, this function takes an iterator, or it takes, I made a custom iterator. I just made a class and I overloaded the correct operators, which also means that I can just throw in a raw array and a bunch of pointers to it, and this function will still work. right? So iterators behave like pointers because we overload the correct operators. And basically that implies that like I can use these functions on, with just pointers. Anyway, so yeah, that's it for today. Any questions? Okay, so next class we'll finish off standard template library and we'll move on to exceptions. Exceptions don't appear on your assignment, but they will, there will be a couple questions on your final exam. And we'll look at the final exam or talk about it either next week or the week after. But that's it for today. Yeah, I guess I have office hours today at 1 if you need any help. And otherwise, please get your assignment in this weekend and your tutorial.